Hello students, good morning. How are you? So firstly, make sure the screen is visible to you and audible to you. If it is, okay, just a second. Yeah, good morning. Okay. So today also we are going to cover some numericals from mechanical properties of solids. Okay. In the previous lecture, we have also seen some numericals. In this lecture also, we are going to see some conceptual problem and also the PYQs and try to understand the concept behind. From this chapter, not so tough question has been asked till yet, but yeah, you can expect a good question from this chapter in G Advanced. Okay, in J Main also, but J Main also the most of the question are formula based and a little bit of concept is required there. Okay, so we will see all the types of possible question that can be framed from this chapter. Okay. Although the syllabus of this chapter has also been reduced, thermal stresses and buckling problems that has been removed from the syllabus. So now, so we will wait for 1 minute more, let the others to be joined, and then we will start. Okay. So are you a single student or a whole, you are watching this lecture from a projector? And what's your name? So we will start the lecture. Okay, okay, Shiva, got it. In regular classes, the ID of yours will be different now. And okay, okay. So let's just start it with this. Okay. So this is the question that we have left yesterday. Okay. So we will start from this question and move forward. Now, consider a steel wire of radius r and length 2L is clamped firmly at 2 points A and B as given in the figure. Figure I will draw, no, not worry about it. A body of mass mx, mass m, it's not x. Okay, this x is not here. A body of mass capital M is hung from the middle point of this wire such that the middle point sags x meter down from the initial position. I found out the x. So figure says like this. These are two rigid support. Initially the wire at this length. Okay. We have hung a body of mass capital M at the middle of it so that it will stretch a little like this. ऐसे ही तो stretch होगा. Okay. And let's say this is the body we have. So length of this wire is what? 12, that is given in the question. And radius of the wire is small r. ठीक है. So कितना sag करता है middle point से? It is given in the question that it sags x distance, x meter down. So this distance would be x. Now we have to find out the x. Okay. Now you know that now the length will become 12 dash because some of the portion of the length has been stressed by this weight, which is capital M into G. Okay. So try to solve this question. Now, so we need to find out this x. Let we assume that this angle would be theta. Same angle would be there, theta. Okay. Since this theta is very small, since theta is very small, then we can assume sine theta approximately tan theta is equals to x upon L, or this distance would be L and this distance also would be L. So tan theta, if you apply in this triangle, let this point be point B. So in this triangle, what will be the value of tan theta? Tan theta would be base, sorry, perpendicular over base. Perpendicular is x and base is L. So tan theta we have here is x upon L, which is you can equate to sine theta because theta is very small. Okay. Now, in this case, we know the tension would be developed in this wire because it is stretching. So tension would be developed. This tension is in this direction and this direction. So if you draw the forces, there is a weight mg in the downward direction. Now, this is the value of T for this one, and here it is this one. Now, if you calculate the angle, this will be theta because this angle is theta. So same angle would be here on the adjacent side of it. And whenever a Z is formed, look this. If this is theta, so this would also be theta. Try to remember this Z formation. Okay. So here also a Z is forming. Look, this angle theta, so this would be theta. Now, it is T cos theta. Similar will be the case will here. T cos theta. Now on the upper side, T sin theta, T sin theta. So two component we have in vertical direction, two component we have in horizontal direction, but in opposite direction. So this T cos theta and T cos theta will cancel out, and this 2T sin theta will equalizes this weight because now this system has achieved equilibrium. So we can say that 2T sin theta is equals to m into g. Okay. Now, now what we can do, we have to find this x and L. So this is equation number one. Let's see. Okay. Now, strain in this because this wire will stressed. So what is the value of that strain? Because when we apply a load at the middle point, it will stress the wire. So wire will elongate. So what is the value of that elongation? So that elongation is given by, let's see, if you consider this section, this one. So the now length of this section would become L dash, and initially the length of this section is L. So if I subtract L dash minus L, I will get the length. So L dash minus L is the elongation of this part. Okay. Now, what is the value of L dash? L dash is nothing but if you calculate this value, this is the hypotenuse of this triangle. So apply Pythagoras theorem. So L dash will become square root of L square plus x square minus L. Okay. If you take this L common from this, it will become L into 1 plus x upon L square raised to the power 1 by 2 minus L. Okay. Now what we are going to do, we are going to apply the binomial expansion. We know that 1 plus x raised to the power n will equals to 1 plus nx plus n into n minus 1 x square by 2. So we will express it by only 1 plus nx term because higher order will be very less. So they are insignificant for us. So L into 1 plus 1 by 2 because n will come in front of this and it is x by L whole square minus 1 because L I have taken common. This 1 will cancel out this one. So we have L by 2 x by L whole square. Okay. This is the value of the elongation that is. Okay. Now, just give me 10 seconds. Just a second. Okay. So sorry for the disturbance. Now, so elongation we have calculated. Now, I want to calculate this tension. So yesterday I have told you a formula that delta L is equals to FL over Y. Here, the force, the load that we have applied is appearing as the tension in the string. So we can say that delta L is equals to tension into original length divided by Y into area of the wire. So now, if you calculate the value of T, it will be YA delta L upon L. Now delta L we have calculated. So tension would become Y into A delta L की value. It is, let's say, L x by L whole square divided by 2 into L. This L. This L and L will cancel out. So tension would become YA upon 2 x by L whole square. Now, in the equation number 1, 2t sine theta is equals to capital M into G. Okay. So 2t, the T tension we have already calculated. It is YA by 2 into x by L whole square. YA by 2 x by capital L whole square. Sin theta we have approximated as tan theta and it has a value of x by L. Again, it is x by L equals to capital M into G. Now, this 2 and 2 will also cancel out. So it will become YA x cube divided by L cube is equals to mg. Now x cube is equals to mg L cube divided by YA. The radius of the wire is R. So we can put the value of area of cross section as pi r square. So it will be mg L cube divided by y into pi r square. The value of x will be x is equals to mg L cube divided by y pi r square raised to the power 1 by 3. So this is the value of this elongation. Now, if anyone have any kind of doubt in this question, I hope you must have a doubt because this question involves various concepts. So this, please ask if you have any kind of doubt or you want to repeat me this question. Okay, do not hesitate. So everyone clear with this question? Write the thing in the chat box if you are clear with this. Okay, so Shiva is clear with this. Now, what about any others? Okay, so what we have did in this question, we have firstly approximated sine theta is tan theta because theta is very small here. So tan theta we have calculated x by L. Then we take up the component of this tension, which is 2t sine theta in the vertical direction, and in horizontal direction it will cancel out. There is only one force to balance this, which is the weight of this block. So we have applied the condition for equilibrium. Now, then we have calculated elongation because for tension, we need the elongation. How much this wire has been stretched or elongate. So for elongation, what we have did, we have take this part of the wire and let's say the length of this will become L dash. Okay. So L dash is the final length. Initial length was L. So L dash minus L as the act as the elongation. We have calculated the value of it will become L by 2 x by L whole square. Then we have calculated the tension in the wire. Now we put it in the equation number 1, put the value of sine theta and calculate the value of x. Okay. Now, next question. So consider a metal bar of mass m is pulled by force F1 and F2. Two ends as shown in figure. Now find out the total elongation in the bar. And let's say this is the F1 and this is F. Now try to solve this question. Student of JNV Ramnagar and the other one that we have as, okay, JNV Dahod. So try to solve this question. Now, are you guys solving this question or not? So what do you think about this question? Is this tough or easy to crack? Just let me know, then I'll start solving it. Should I start? Okay, solving. Got it. So try to solve this question. You have 1 minute, okay, from now also, and 1 minute you have already taken. So there are different forces now, and one thing I want to mention that F1 is greater than F2. You can take F2 is greater than F1. No problem in that. Okay. As the forces are not equal here, you will see F1 and F2 are different. So there would be a net external force in this bar. Okay. And due to that external force, this bar would be accelerate. Okay. Now, I'm solving this question. You guys will match your answer. Okay. So I have taken a cross section here at a distance x from here. Okay. Now I assume that the tension developed at this section would be T. So I can assume this is at like this. This is of length x, this is F1, and this is T. Okay. Now, if I find out the acceleration of this bar, let's say it is A, because F1 is greater than F2. So net force is in the direction of F1. So acceleration of the system or the rod, acceleration of the bar is given by F1 minus F2. Net force is equals to mass of the rod into acceleration. Now, acceleration is given by F1 minus F2 by capital M. This is equation number 1. Now, if I talk about this, so for this is also accelerating with an acceleration, same bar ka part hai. The same acceleration is there. Now, if I apply the Newton's law for this, so it will result in F1 minus T. Why I'm doing this? Why I'm doing this? Why I'm finding out the tension? So that we can consider a section of dx length and find out the elongation, because on dx there is also the tension T. Okay. So we firstly find out the tension and then we take a elemental length and we will assume that the elongation of this would be dl and then we integrate it for the entire length. Got it? Now F1 minus T is equals to mass of this section. Now the complete mass will not come here. Okay. Mass of this section. Now you know that this L length, let's say the length of this road is capital L. Okay. This L length has a mass capital M. So unit length has a mass of M by L. So what is the mass of X length? It will be M by capital L into X. So I can put the net force is equals to mass of the X length into acceleration of the bar. F1 minus T is equals to mx. What is mx? We have calculated it m by L into x. And what is the value of acceleration? It is F1 minus F2 by m. You can cancel out this m. So F1 minus T is equals to x by L F1 minus F. Now, for the value of tension, you will put this in this side and take tension in this side. So tension would become F1 minus x upon L F1 minus F2. Now from here you can see this tension is varying with x. So that is why we cannot completely apply this for the entire length initially. So what do we have to do? We will consider a section of dx length. Okay, I will do in the next page. So what we will do? We will consider a section of dx length Now you will understand now why I'm taking this as dx, because our tension that is developing a stretch in this bar is varying with x. Okay, so that is why I have to consider a small length for which I can assume this tension to be constant and calculate the differential elongation. So let this elongation in this ds section is dl, or we have assumed this as dl. Now, again the same formula. Formula will not change. For dl length, I have told you that delta L is given by FL over YA. This is the Ramban of this chapter. Okay, like it is the Avenger of this chapter. So try to apply this formula will apply in every situation. If this DL, so what you have to do, you this take this length or the original length. What is this? So we are applying it for this element which has a length of dx. So it is F. F is nothing but the tension that has been applied in this. Tension into L. L means length of this section which is dx. So T dx divided by y into a area, base area will be same. Okay. Now, so DL you have as, this is not driving license. This is DL, that differential elongation in the bar. So tension we have already calculated, which is F1 minus x upon L, F1 minus x upon L, F1 minus F2. This is the value of tension into dx divided by YA. Now, for complete elongation, we will calculate it from 0 to L. The limit will be 0 to L because x can vary from 0 to L. Look, x we have measured from this end. So at this end, x would be 0 and at this end, it would be capital L. So 0 to capital L. Now, YA is a constant, so we can take it out from the integral. Now this will become delta L, the complete elongation, integration of differential elongation. Now, 1 upon YA we have taken now. So integration will be distributed to this expression. So 0 to L f1 dx, इधर से इंटीग्रेशन मल्टीप्लाई हो रहा है, इधर से dx माइनस इंटीग्रेशन 0 टू L x बाई L f1 minus f2 dx. Now delta L will become 1 upon YA. Now integration of any constant will become f1 into x. Integration of dx will become x and limits are L to 0. So it is x 0 to L minus this f1 minus f2 are the constant and L is also constant. So I can take it out as the integration. The integration inside will be left as x dx. I have told you integration of x dx is x square by 2. Now x square by 2 and limits are 0 to L. So delta L here is 1 upon YA f1 into L minus f1 minus f2 divided by L into L square by, okay. Now you cancel this L, 1 power. So you will see here what will left. Delta L we have as 1 upon YA into F1L minus F1, and this L will multiply divided by 2 plus F2L divided by 2. This is F1L, this is F1L by 2. So we will have as F1L by 2. Now delta L will become 1 upon YA F1 L by 2 plus F2 L by 2. So delta L you have as F1 plus F2 L divided by Y into T. Okay, got it? So what you have to do, if any situation like this, you will find out, like the road is given to you and there are different forces, let's say 10 Newton and 8 Newton is there, and the length of the wire is 2 meter. So in that, if you are asked to be find out the total elongation, then what will you do? Delta L is the sum of these forces, 18 into length, which is 2 divided by y into area. Okay, and that are also been provided to you. It become simple. Okay, got it? So anyone, any kind of doubt? If you have, you can ask. No. Look at this question. Steel wire 6 meter length is stressed through 3 millimeter. The cross-sectional area of the wire is 2 millimeter square. If Young's modulus of elasticity is of steel is 2.0, 10 raised to the power 11 Newton per meter square, then you have to find out energy density of the wire and elastic potential energy stored in the wire. Okay, Shiva. So you have no doubt. Got it. Anyone else have any kind of doubt, they can ask. Okay. Now, try to solve this question. It's a very easy question, let's say. So I am solving it for you. Next question you will solve. Okay. So length of the wire is given as 6 meter. Elongation, which is stressed through 3 mm. So this is the elongation. Delta L is given you as 3 mm. All the units are in meter, so we will convert it into meter also. 3 into 10 raised to the power minus 3 meter. Because 1 meter equals to 1000 mm or 10 raised to the power 3 mm. Okay, so delta L is also given to you. Area of cross section is also given to you. It is 2 mm square. We are converted into meter. It will become 2 into 10 raised to the power minus 6 meter square. Because mm का स्क्वायर हो रहा है तो 10 रेज टू पावर माइनस 3 will be squared. Okay, that is minus 6. Y is given to you as 2 into 10 raised to the power 11 Newton per meter square. Okay, now energy density you have to find out. We know that energy density small u is nothing but 1 by 2 times stress into strain. Hmm? But here nothing is provided for stress, but you do not have to worry. We know the Hooke's law. So according to Hooke's law, what we can say, the stress is equals to y times strain, and that stress should be longitudinal stress. Okay. Now put the value of this stress in this expression. So energy density would become U is equals to 1 by 2 times y into strain square. Now strain you can easily calculate it. Strain is given by what? Delta L over original length. Change in length over original length. It will be 3 into 10 raised to the power minus 6 divided by original length is 6 meter square. 1 by 2. What is the value of y? It is 2 into 10 raised to the power 11. This will become 9 into 10 raised to the power minus 12. 6 to the 12 divided by 36. 9 4 ja 36. 2 and 2 will cancel out. So you will have as so value of u will be 1 upon 4 into 10 raised to the power minus 1 because this power will cancel out. So the value of energy density would become 0.25 because 1 upon 4 is 0.25, 10 raised to the power minus 1, or what you can say, you can take as 2.5, 10 raised to the power minus 2 joule per meter cube. Got it? Anyone? Any kind of doubt? So this is the simple formula we have and we applied. Okay. Now, note this down and try to solve the next part of it by the definition of energy density. Okay. Energy density is what? Energy density is the ratio of potential energy to the per unit volume. Okay. So, the energy density is nothing but elastic potential energy per unit volume. And energy density you have already calculated. So calculate the value of an elastic potential energy. Okay. Try to solve this. I'm giving you 1 minute to solve this. Okay. Okay. One thing that we have mistakenly right here, and you guys are not paying attention to that, is that we have taken delta L 3 10 raised to the power minus 3 meter. But here we have taken it as minus 6. So it will be minus 3. So the power will become here minus 6. So 11 into minus 6 will become the power 5. So now this will become power 4. Okay. So try to be attentive now. Try to be attentive. Focus on the question. And wherever you find the mistake, just let me know. Now, u we have find it out as 2.5 10 raised to the power 4 joule per meter cube. Now, u is nothing but elastic potential energy per unit volume, u by v. So, elastic potential energy is u into v. U is 2.5 10 raised to the power 4. Volume we can calculate. Volume is nothing but area into length. 2.5 10 raised to the power 4. Area is given to you as what? Area 2 into 10 raised to the power minus 6. 2 into 10 raised to the power minus 6 and length is given you as 6 meter. So this will become 2.5 to the 5, 5 6 the 30 into 10 raised to the power minus 2. It will become zero point 0.3 joule. So energy of this system is, of this bar is 0.3 joule. Got it? Okay. Now this is the question asked in JEE Main 2023. Try to solve this question. It is based on the same concept I have told you in the previous question. So try to solve this. I'm giving you 1 minute, not more than that, because this question will be able to solve in 1 minute. I'm writing the given parameters that is given to you. So y It's clearly written here, 7 into 10 raised to the power 10 Newton per meter square. Elastic strain of 0.04% it is given. So convert it into numerical value. You will divide this expression by 100. So elastic strain, which is delta L by L, is equals to 0.04 divided by 100. This is the value of strain. Now we have to find out the energy per unit volume in SI unit. Okay. So we know that energy density it is asking, because energy density is the energy per unit volume. So it is 1 by 2. Option A you are. Okay. We will check. 1 by 2 y into strain square. We are applying the direct formula to this. 1 by 2 y we have as 7 into 10 raised to the power 10. Strain. Strain we have 0.04 divided by 100 square. 1 by 2 into 7, 10 raised to the power 10. It is 0.04 multiply 0.04 divided by 10 raised to the power 4. This power 4 will cancel out this power 4 and this power will become 6. Now 2 cancel out this 0.02. These are the 2 minus power. These are 2 minus power. So this power will become -4. They will cancel out this again. Power we will have as 2. 4 4 ja 16 and 16 7 ja. Sorry. What we have did, this will become zero point 0.2 na. So it will become 4 2 ja 8, 8 7 ja 56 and 10 raised to the power 2. That will become 5600 joule actually per meter cube. But that is not written, so 5600 is. So very good, Shiva and student of JNV Ramnagar. Very good. Keep it up. Now, this question. A light rod of 4 meter is suspended from the ceiling horizontally by mean of two vertical walls. This is a light rod. Means iska weight is not considerable. Only the length is considerable. Is suspended from the ceiling horizontally by means of two vertical wires of equal length tied to its ends. Now, one of the wire is made of steel and is cross-sectional area of 10 raised to the power -3, and other is of brass, cross-section area this. Now, we have to find out the position along the road at which the weight may be hung to produce equal stresses in both the wire. Okay, so this is the situation. We have this ceiling. This is the one of the wire. This is second wire, and this is the road that we have hung. The length of this road is nothing. The length of this road is not nothing. It is 4 meter. Okay. And let's say this is the wire of steel. So tension develop in this wire is TS. And this is the wire of brass. So tension develop in this is represented by T. Now weight of this wire will be acting downward. Okay. This is weight of this uniform rod. Okay. Now it is given in the question. Firstly, we will write what is given in the question. It's a easy one question, not so much heavy question is this. So a light rod of 4 meter. The length of rod is 4 meter. We have already taken. Now, one of the wire is made of steel and cross section. So we will say that area of steel wire is 10 raised to the power -3 meter square, and area of brass wire is 2 into 10 raised to the power minus 3 meter square. Okay. And one of the thing that is given, that stress in wire, just a second, in wire of steel is equals to stress in wire of brass. So we know that stress is nothing but load upon area, and load we have taken at tension. Tension is the factor that is causing the stress in this wire. So tension of steel divided by area of steel is the stress in steel. It is equals to the tension of brass divided by area of brass, because stresses are same. Now area of steel and area of brass, we have the values. Put the value. So Ts upon area of steel will become 10 raised to the power minus 3. TB divided by 2 into 10 raised to the power minus 3. This will cancel out. So you will have Ts is equals to TB by, okay. Now we have to find out the position where we place this mass. This is not the weight of this road. यहाँ पे this is the weight of road that we hung. Okay. So assume that this distance from the steel wire is x. Let me place this wire, this road such that it is at the weight which is acting downward. It is at a distance x from the steel wire. So this distance will automatically become 4 minus x. Got it? Now, if this system is in equilibrium, we know that. So for equilibrium, what we will do, we will, this, let's say this point is D or P. So what we will do, for equilibrium, the moment of tension force, or we will say the moment of forces about P is equals to 0. So at this point, if this system is in equilibrium, so moment about this point will be 0. Got it? So we will take the moment now. So moment about this point P. So this tension, let's say I will draw it in the next page. This is the tension P of steel. This is tension of brass. This is the point P. Now this weight, if I talk about the moment about this weight is passing through this point. So the moment of this weight is 0 about this point P. Okay. If I talk about the moment of this Ts, so it will be given by force multiplied by the perpendicular length from the point. So it is x, and in this case it is 4 minus x. Now Ts will try to rotate this rod clockwise, and TB will try to rotate this rod anti-clockwise. So they are equal and opposite. We can say that Ts, if I consider clockwise to be positive, Ts into x minus, because TB will be negative, TB into 4 minus x equals to 0. Ts into x is equals to TB 4 minus x. Ts is nothing but we have calculated TB by 2. So Ts is TB by 2 into x into TB 4 minus x. यहाँ तक clear है सबको? Any kind of doubt? Now we can cancel out this TB. So it will become x by 2 is equals to 4 minus x. It will become x is equals to 8 minus 3x, sorry, 2x. So 3x is equals to 8, x would be 8 by 3. meter. So we place this mass at x is equals to 8 by 3 meter from a steel rod, so that the system will be remain, the equal stresses would be produced. Got it? It is clear to everyone? Is this clear to everyone? I'm talking to you, student of JNV Ramnagara. Okay. So if you have any doubt, you can ask. Now, before solving these question, I want you to try this question. The Young's modulus of a steel wire, and this is a question of JEE Main 2023. Okay, one thing I want to ask you, do you guys want me to add some question from NEET also? If you want so, then put a yes in the chat box. So the Young's modulus of a steel wire of length 6 meter and cross-sectional area 3 millimeter square is given as this. The wire is suspended from its support on a given planet. A block of mass 4 kg is attached to the free end of this wire. Okay, so in the next session would be of fluid mechanics. So try to be attentive because very important question will be discussed in that session and very conceptual, because the weightage of fluid mechanics is also being reduced. So the number of question that has to be asked from these topics will be increased. Okay, so try to be attentive in the next weekend and in the regular classes also. So a block of mass 4 kg is attached to the free end of the wire. The acceleration due to gravity on the planet is 1 by 4 of its value on the earth. The elongation of the wire. Very good question and very conceptual. If you go along the concept, you will never find a worry about this question. Do you remember the Avenger of this chapter? The Avenger formula. So this is our Avenger formula. And what is that? The elongation is given by load applied to the length divided by YA. Okay. This is our Avenger formula. Okay. Now, so Y is given. Firstly, we will write what is given in this question and you will also try to solve this. So Y is given as 2 into 10 raised to the power 11 Newton per meter square. The wire is suspended from its support on a given plane. किसी planet पे ये कोई support है and this wire is suspended. Free end of this wire has a weight m into g dash, not gravity of the earth will act on that planet. Gravity is different, so that is why the weight will be different. The mass will be same, 4 kg. Now, length of the wire is given you as 6 meter. Area is given to you as 3 mm square, which is 3 into 10 raised to the power minus 6 meter square. Okay. Now, acceleration due to gravity on that planet we have considered at g dash is 1 by 4 of the original 1 by 4 of the gravitation on earth. Okay. Now this weight produce the tension in this wire. Okay, and tension will be equal to this load. So load applied here is mg dash. So we have the formula, the elongation is nothing but load applied multiply by length y into a. F is nothing but mg dash. Length we have given as 6 meter divided by y. 2 into 10 raised to the power 11. Area is also given as 3 into 10 raised to the power minus 6. Now, mass is 4 kg. G is G by 4. And we have to take G on earth as 10. So it is 10 by 4. So 10 we have multiply here in the numerator. 4 we will multiply in the denominator. So 4 into 10 into 6 divided by 2 into 10 raised to the power 11. 3 into 10 raised to the power minus 6. 2 2 ja 4. 3 2 ja 6. This 1 cancel out the 1 power. So this will become 10 raised to the power 10. In numerator we have 4. In denominator we have 10 raised to the power 10 minus 6 will become 4. So it is 4 into 10 raised to the power minus 4 meter. Now, anything we have done mistakenly here? Yes, of course. Why not? Because we are the human, so we can make mistake. We have take this g dash as 10 and not multiply the 4 in the denominator. So this 4 will also come here. The 4 and 4 will cancel out. So it will become 1 into 10 raised to the power minus 4 minus 4 meter. Now convert it into centimeter. So 1 into 10 raised to the power minus 4 multiply by 100 will become in centimeter. So it will become 10 raised to the power minus 2 centimeter, which is 0.001 centimeter. This is not the option. So obviously, the millimeter is the answer. Because in 1 centimeter you have 10. In 1 centimeter you have as 10 mm. Multiply this expression as 10. So 0.01 into 10 will become 0.1. Any doubt in this question? Clear enough? Okay. So this is it for now. Remaining question we will discuss in the regular class or the weekend class whenever we get the chance. Okay. So I have enjoyed this session with you guys, and I hope that you have also enjoyed this session. Thank you so much for being attentive. It's a wonderful session with you guys. Thank you so much.